Alright, so say you're given an array of integers in increasing order like this. So say we had like 2, 5, 8, 9, 15, 20, and 32. Right, and we're asked to find a number inside of this array in logarithmic time. Well, first we need a number to look for. So say we're going to look for 8. So I'll set the target equal to 8. And in binary search, we have 3 different pointers. So our first pointer starts at the beginning of the array, and we'll call it, this is our left pointer. And then the right pointer starts at the end of the array, and we'll call it right. And then we have a middle pointer. The middle pointer is put obviously in the middle. And what we do is we ask 3 different questions. First we ask, is the number at the middle pointer our target number? That's the first question. So we say, is the num at the mid equal to target? And if that is false, we ask another question. We ask, is num at mid greater than the target? And if that's false, we say, is num at mid less than the target? So we ask these 2 questions, and one of them is bound to be true. So we ask the first question, is 9 our target of 8? No, it's not. Is 9 greater than the target? Well, that's true. So when this is true, what we do is we relocate the right pointer. And the right pointer is going to be relocated to the middle pointer minus 1. So the right pointer will be located right here now. And then we recalculate the mid pointer. And the mid pointer will be the median between our new right and our left, which would be right here. And then we ask the same question. Is 5 our target? Well, no, it's not. Is 5 greater than our target? No, it's not. Is 5 less than our target? Yes, it's less than. So that means we take our left pointer and place it 1 in front of our mid pointer. So our left and right pointer will both be targeting this 8 right here. And then we take the median between the left and the right pointer, and since they're both on the same number, the median would be that number. And so our mid pointer would be at this 8. And then we ask, is our number at the mid pointer equal to 8, which is true, and we've found it. All right, that's one example. I'll go over one more with a different number or a different target. And this time we'll say our target is equal to 20. So I'll set target equal to 20. All right, we start here at the beginning of the array, our left pointer, and then we start here with our right pointer, and our mid pointer is here. Now we ask the question, is a num at our target greater, or is it equal to it? No, 9 is not equal to 20. So is it greater than? No. So is it less than? And that's where it is. So when it's less than, we move the left pointer 1 in front of the middle pointer, recalculate the mid pointer, just like that. And then we ask the questions again. Is num at mid, so num at 20, equal to our target 20? Yes. So we found it again. All right, so binary search works like this, where we have a value of n, which is the size of the array, and we split that n in half. And then on the next iteration, we split that half in half. And then on the next iteration, we split that half in half, all the way down until we get n over 2 to the x, which approximately will be equal 1. So this x right here represents how many iterations it would take to find our element, right? So if 2 to the power of x equals n, then x will equal the log of n, which is equal to our time complexity for the binary search, right? So if we plug n for like 32, right, it would look something like this, where 32 over 2, and then it would go all the way down until 32 over 2 to the 5th, which equals 1. And if we plug 32 here into this right here, we would get an answer as 5, which is how many iterations it took for these two values to be equal. Right, so if we compare a logarithmic search to a linear search, we'll have time on the y and then size of n on the x. A linear search, say we're given O of 32, it would take 32 different iterations to find the element we're searching for. But with binary search, it would only take 5 iterations to find the element that we're searching for, so a lot faster. And it only gets more drastic the bigger the number. So say n was like 100,000. Say n was like 100,000. We plug this 100,000 into our formula here. We would get the amount of iterations for the binary search to be like 15, while the iterations for the linear search would be the same number of 100,000. So obviously much more optimal to use a binary search than linear search. All right, so how do we actually implement binary search in code, right? So I have this prompt right here that says, given a vector of integers nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, you return the index, otherwise you return -1. And the constraint is the algorithm must be written in logarithmic time complexity. Right, so first off with binary search, we have to initialize our pointers. So I'm gonna create integer left, which would be equal to 0, and integer right, which would be equal to the end of the size of the array -1, which gives us the last index. So nums dot size -1, and then I'm gonna make a mid, but I'm not gonna initialize it to a value. I'm just gonna declare it just like that. Now what we're gonna do is say while left is less than or equal to right, and right is less than nums dot size -1. Just like that. That's just so that we're always in bounds of the array, and left never exceeds right, because we never want our pointers to go past themselves. If they're in the same spot, that means we've looped as many times as possible. All right, so now what we want to do is calculate our mid. So our mid will equal the left plus right divided by 2, just like that. And then after this, we want to check if the nums at that mid pointer is equal to our target. And if it is equal to our target, we can just turn mid, which will give us mid as the index of where the target is. All right, so else if nums at the mid pointer is greater than the target, just like that. If it's greater than the target, which means our mid pointer's here and the target's on this side, I'm sorry, our target would be on this side, we want to take the right pointer and put it to mid -1. So our right pointer will equal the mid pointer -1, just like that. And then else if the nums at mid is less than a target, we want to take the left pointer and set it equal to the mid plus 1, just like that. And then on every iteration, the mid will be recalculated with our new values of left and right. And by the end, this will happen. But if this does not happen, however, say we get to the end of the while loop and we still have not found our mid value here, we're going to return -1, just like that. And that should solve the binary search problem.